Hello everyone and welcome back to another video in our Autodesk Inventor professional tutorial. In the last video we talked about the mate and flush constraints, which are the most commonly used ones. In this video we're going to do a quick exercise on them. And a good example for mate and flush constraints is a wooden pallet. And if you're not familiar with it, let's just Google it real quick. Go to Google and type in pallet, go to images and select the first result, and let's zoom in. This is a standard pallet, 48 inches by 40 inches, and you can tell that there are multiple pieces, so it's an assembly. There are nails that they use to hold it together, and some pieces are thicker than the other ones, and some pieces are wider than the other ones. So I'm assuming that this thick one is a 2 by 4, and this thin one is a 1 by 4. And we're going to create those two components and use the flush and mate constraints to basically place them in the assembly the way we want them to be placed, the way they're going to be assembled. Um, I've worked at different companies in the past, and these companies produced products that would be mounted on these pallets and shipped to the customers. And we used CAD software to design these pallets because these products would be in various sizes, so we couldn't use standard size pallets and we couldn't purchase them. So we had to make our own pallets, which means that we had to allocate space on the shop floor. There would be people who would have nail guns and create these pallets. And obviously, there's raw material, there's labor associated with it. So if you're not careful, you can really waste a lot of time and a lot of resources. You can make mistakes. There would be a lot of rework. And actually, even worse, you can make a pallet that would fall apart before it goes to the customer. So we use the CAD software to design our own pallets so that it would provide sufficient support for the product. And also, it would use sufficient amount of uh, material, and it would take less time because we created work instructions using the CAD software using Autodesk Inventor, which improved the efficiency numbers of the production floor. And sometimes these products would even go to companies in different countries, in different continents, and they would have to be crated so that they can be stacked on top of each other in a container or in a truck, and that crate would provide protection from different sides and also from the top. And that's when it gets really complicated because you need to know what length you need to cut and how they need to be oriented, how they need to be assembled. So those work instructions really helped us save a lot of time and resources. And it made it a lot easier for the people on the shop floor as well. So we created this entire binder for the crates and pallets for various types of products. Now we're going to use this as an example to do an exercise on mate and flush constraints. Let's keep this image available, and let's go back to Autodesk Inventor and maybe click on this drop-down menu. We can go to assembly mode and create our components there using the create component function. But I want to use the part mode this time, and we're going to create two components. The first one will be 2 by 4. The second one will be 1 by 4. In real world, 2 by 4s are not really 2 by 4s. Actually, it's like 1.75 inches by 3.5 inches, I think. But we're not going to do that. We're going to use 2 by 4 by 1 by 4. So let's create a 2 by 4 first. Let's use the XY plane, create a sketch on that plane, and let's use the 2-point center rectangle. I have been using millimeters as my unit of measure since the beginning of this tutorial. I could change it to inches for this exercise video, but I didn't want to, and I wanted to show this little trick. I think I mentioned it once before as well. Instead of just changing every time you work with different unit of measure, instead of changing those units and the settings, you can just come here and instead of entering millimeters, you can enter 4IN, and it's going to recognize it as inches. And you can hit tab and go to the width, and you can enter 2IN. It's going to recognize it as 2 inches. Now let's click OK and get out of that command. Notice that it is still displayed as millimeters, but if you double click, it will show you as 4 inches. Same thing with the 2 inches here. It displays it as millimeters, but if you double click, it's going to show you that it's actually 2 inches that you entered. Now let's finish the sketch and let's extrude this. But how much of an extrusion are we talking about? We're creating this vertical piece here, so that's 48 inches long. So this is going to be 48-inch extrusion. Again, I will enter IN, so it's not going to extrude it by 48 millimeters, but it's going to be 48 inches. Now I created my 2 by 4 by 48-inch wooden piece. Now I can go to the material library so it looks a bit more realistic. I can I can press W on my keyboard and go to the W because it's alphabetically ordered in the material library. And you can select yellow pine so it looks somewhat more realistic. Now this is my first part. Let's save this. I created this folder called Pallet on my desktop. You can do the same thing. Let's change this part 1 to 2 by 4 .ipt save. Now I created my first component. Let's go to the second one now. Again, start a 2D sketch. Um, that is going to, oh, sorry. I need to first start a new part and go to the part mode for part 2. And now start a 2D sketch and select XY plane. And do the same thing. Select the 2-point center rectangle, use the origin point, and this time, this is again 4 inches. Hit tab, and this one is going to be 1 inches. And hit enter. And now this is my 1 by 4 rectangle. Now let's finish the sketch and extrude. I believe this is going to be 40 inches. Yeah, so this is the first component we created, which is 48-inch long. This is the second component we are creating, which is going to be 40-inch long. And I know some of these pieces in this image are wider than the other ones, but we're not going to do that. We're just going to use the same width because, again, our priority here is covering the mate and flush constraints. Let's go back to Inventor and extrude this by 40 inches. Again, do the same thing. From the drop-down menu, go to Wood and select Yellow Pine so it looks consistent. Now let's save this again in the same folder, Palette folder, and name this one as 1 by 4. Hit Enter. So now from the drop-down menu, let's select the assembly. Again, we could have done all of this in the assembly mode as well. And now we can place all these components from place component function. We covered that in the previous videos. But I want to do it this way this time. I want to select 1 by 4 in the model tree here and hit Control C on your keyboard. Come to the assembly and select Control V. Press Control V on your keyboard. And that way you will basically copy paste the component in the assembly. Let's do the same thing for 2 by 4. Control C, go back to assembly and Control V. Now my 2 by 4 is also in the assembly. Now I don't need these 2 by 4 and 1 by 4 open, so I can close them. Because now I can copy paste these as many as I want. Notice that I copied and pasted 1 by 4 first, and that's why Autodesk Inventor added the thumbtack icon next to it, which means it is grounded. This is my grounded component because every time you're creating an assembly, you need to have a reference component that's fixed in space. So everything else can be floating around, but you can use constraints to basically create relationships between them using that first reference component. So this is the first component I added, so Autodesk Inventor automatically grounded that component for me. So this is not going to move around if I try to drag drag it around, but this will move around. I kind of want this to be grounded. I don't want this to be grounded, so if you want to change that, you can right-click on the grounded component and uncheck grounded, and now this can move around. And I want this to be my grounded component, so I can right-click and select grounded. Now this is not going to move around. Now it's my fixed component. Going back to the image, this kind of stays vertical here, so we can do that from XYZ coordinates, but let's just kind of rotate around and we can, kind of make it look like vertical here in the assembly. Obviously, in the image, I need 3 of these vertical 2 by 4 pieces, so I'm going to need 2 more. Again, I can do Control C and Control V. I can place more components. I can do all that. There's another way to do it, which is you can kind of drag and drop, and that's just going to basically copy and paste the component. You can then drag and drop it from here. Now, my first component is grounded. The other ones are floating in space. So now I need to use the constraints to make sure that they don't move around and they are fixed in position based on the information that I provided to Autodesk Inventor. So first of all, I want them to act like they're sitting on the same surface, almost like they're sitting on a tabletop or something. So I need them to be constrained from the bottom surfaces. So I can use the constraint button here in the relationships menu, or I can use the right click menu and select constraint. So here you have two solutions in the mate constraint. The first one is mate constraint. The second one is the flush constraint. And you can see the previews. One mates these two surfaces against each other. The other one make them flush. So for example, I want this surface to be flush with this surface. If I accidentally select mate, which is what's selected right now, if I accidentally select that, it's going to basically uh, put those two faces together. That's what it's going to do. But this is a toggle, so I can always change it. I can change it to flush, and now it is going to, right now it looks like they overlap, but what it's doing is it is using the flush constraint to make sure that these surfaces are constrained on the same surface. So let's click apply, and then this surface also will be constrained with this surface. Now that is also constrained as well. Let's hit OK. If I continue to hit apply, it will keep this place constraint window available for me. If I hit OK, it will apply all the constraints, but it will exit from the constraints window. Now again, the grounded piece is not going to move, but the other pieces are going to move. But the only thing that is not going to change is the fact that they are constrained from these bottom surfaces. So that's not going to change whatever I do unless I delete the constraint. Now the second constraint I want to add is I want this surface to be flush with this surface so they kind of stay aligned here. And I want, again, this surface to be flush with this surface. So they are kind of like, almost like there's a wall here, and you kind of push all three of them against that wall. So those surfaces line up. So let's go back to the constraint menu and select the flush constraint and select this surface and this surface. Just like the preview, now these two surfaces are flush. And I can hit apply, so I still have the constraints available in this window. And I can select this surface with this surface, and now they're going to be flush as well. So now I hit OK and get out of that. So now what I did is they are on the same surface. From the bottom surfaces, they're flush. And also from these, this front end surfaces, they're also flush. So the only thing that changes is the fact that they move kind of away from the grounded component, and they can be moved closer to the grounded component. Going back to the image, these are, again, 48 inches this way and 40 inches this way. And I need to put 40 inches, I need to put these three pieces in the 40-inch space. So this outer surface of this first component and the outer surface of the third component will be 40-inch away from each other. So let's go back to Inventor. So this surface here is going to be 40-inch away from this surface. So how do we do that? We can, again, hit Constraint and select this surface. And there are different ways to do this too, but I just wanted to show it this way because it's interesting a little bit using the offset value. And then we're going to select this surface. Notice that it just applied the mate constraint immediately because we did not enter any distance here. So if we enter 40 inches, notice that it just placed it 40-inch away, but it placed it on the other side. I want it to stay on this side right here. So offset value always considers this faces that look at each other as the positive value. So if I enter minus sign here, it's going to place it in the other direction. So now you can already see it highlighted. This surface here is 40-inch away from this surface. So let's hit apply. Now the only thing that's going to move is this piece. This is not going to move anywhere because I applied three constraints that fixed it in that position. This was already grounded. Now this piece, I have two constraints that I applied here, but the distance, I did not apply that constraint yet. So let's do that. I know in the previous videos, I always encouraged you to use the center point rectangle when we're drawing rectangles in a sketch mode. This is a very good example of why using the center point rectangle, it can be very useful. So what I want to do is, I know that the middle of this component is 20-inch away from the outside surface of this component. So because this is 40-inch in total, right? This surface to this surface is 40 inches. So the middle of this component is 20 inch, so half of 40 away from the outer surface of this first component. So how do we do that? We can go to constraint again. Again, there are different ways to do this as well, but I wanted to show this one intentionally. I can select this component, but I want to select the middle of this component. How do I do that? I can go to the 2x4 and expand the origin point, uh, and I can just mate it with that component. So this is the second one, that's why I couldn't select it. This is the third component in the assembly, so I'm going to have to expand this part. So let's constrain this, select this outer surface, go to the third component, which is this one in the middle, expand the origin folder, and find the plane that cuts the part right in the middle, which is that XZ plane. And enter 20 inches and select the XZ plane. Well, it didn't like it. What's the problem here? Did I select something wrong? Let's just try it again. Oh, yeah, it wanted me to select the flush. So, but it put it on the other side, so I'm going to change it to negative again. So it would put it right in the middle. Hit apply, and it cancel. So now everything is constrained and nothing moves around. Now I can start adding my 1x4s. Looking at the image again, I know that they put 3 here, but what I'm going to do is I'm going to put 1 here, 1 in the middle, and 1 in the end. So go back to Autodesk Inventor, now hit constrained, and let's say this surface is going to be mated with this surface. So it mated it, but I didn't like the orientation. I wanted this 1x4 to go this way, right? And that's okay. We can take care of that with the other constraints that we're going to add. So let's just hit apply. So we have this window available to us. Now I want this surface to be flush with this surface. Now it's in the right orientation. But there's one more thing left. It's kind of somewhere in the between, somewhere in the middle. I want this surface now is to be constrained with this surface using the flush solution. So let's select this surface and this surface. Now it is in the right location that I wanted it to be. Let's hit OK. Let's cancel. And now this is not going to move around. I need one more. Actually, I need two more. One for this other end and one in the middle. So again, let's just add one more here and then one more here. And now let's do the same thing. Go to constraints, select this surface, select the bottom surface, and then hit apply. Change it to flush. Now I want this surface to be flush with this surface. Hit apply and select this surface with this surface, and now hit apply. Again, do the same thing with the middle piece. I want this surface to be mated with this surface. Hit apply and go to flush solution and this surface to be flush with this solution, with this surface. Hit apply. Again, I have the, let's again exit out of this. I have the same problem here. This piece now is constrained in this direction. It doesn't go up and down, but it moves right and left because we did not assign the distance between these components. So looking at the image again, this middle one is right in the middle of the 48-inch piece. So instead of 20, this time it's going to be 24. So 48 divided by 2 is going to be 24. So let's do that. Right click, constrain. Let's select this surface and select the midpoint, mid plane of this component. So let me just exit out of this, make sure that I'm selecting the right component. I will highlight this. So this is the one I'm going to deal with. So right click, constrain, select the outer surface of the 1x4 that I'm going to use as a reference, and then go back, open the part I'm going to modify, expand the origin, and, oh, not this one, sorry, this one. Expand the origin, and I need, yes, this one that's cutting the part right in the middle. So that's the YZ plane. And again, I'm going to enter this time 24 inches. So let's see if this works. It didn't work because again, I did not change the solution to flush solution. So if you get these alarms, uh, don't worry. All you have to do is just edit the relation. You can cancel the operation. You can try to do it again, or you can edit the relationship, which is going to bring you back to the place constraint window. And now you can toggle and you can see which solution you should be using until you are 100% familiar with it. Well, with the flush solution, I was able to place a viable constraint here, but it's not in the right location I want it to be. So again, it wants me to change the offset to negative. So instead of putting the constraint on this side, it's going to put it on the opposite side. So let's click apply and exit out of this. Now this should not move around, this should not move around, this should not move around, nothing moves around. Everything has a fixed location, defined location in the space. So now we could have done this using the parameters, we could have done this using the configurations, we could have done this using the circular, rectangular patterns. Uh, just there are so many different ways to do this, but I'm intentionally doing it this way because we are trying to do some exercises on mate and flush constraints. Right now, for example, we can mirror this using the midplanes of this component and save a lot of time. But let's do it in a time-consuming way, but it's just a good exercise so we get used to it. So this time on the top section, let's add one here, one on the other side, one in the middle, and maybe one more in between. So total of 1, 2, 3, 4, 5 of them. So again, we come back this time. Let's Control C, Control V. So we have this part here that's not defined. So let's just add constraints. So I'm just going to get faster a little bit. Go here and constrain it with this, and then made it and with this, and then made it with this, and then we have the same thing here. Again, we're going to constrain that here with this. And again, we're going to apply a flush constraint with this surface to this surface. And then we're going to apply a flush constraint to this surface to this surface. Now we're going to add another one in the middle, right? Just like this one. So let's add another one and go to this surface and constrain it with this surface. Go to flush constraint, and this surface is going to be constrained with this surface. And let's see, this one is 48 inches, so it's going to be 24 inch again. So let's constrain that with the outer section. This time I'm not going to make the same mistake. Hit flush and negative 24 inches with the bottom section of the origin, midpoint of this part, which is going to be YZ right here. If you don't know which plane to select, just hover on it and it will just show you a preview of that so you know you're selecting the right one, and hit apply and cancel. Now I created this palette as well. But there are big gaps here in between these two pieces and these two pieces. So most likely I will add two more. So come back here, add this one here, and this one here, and again come back to this one here and made it with this surface. Um, Oops, I made a mistake. I forgot to change the solution, so now it made it flush, which looks unrealistic, right? It overlaps in the design. Again, it's a toggle. Change the solution to fix the mistake and continue to apply the constraints. If that happens to you, again, don't worry about it. Just that's a good exercise as well. So now what do we have? These are not equally spaced. I haven't spaced them yet, but these are all fully constrained. So now the midpoint of this to outside of this was 24 inches. So this is going to be, so let's see, this, you can always go to the measure here from this to this. It's 18 inches. So from this to the middle point of this will be 9 inches then. You can use that as well. So let's constrain this with uh, this here and this one, origin plane, and select this here and enter 9 inches. I put it on the other side, so we're just going to put it on positive because we selected this internal surface. That's why it didn't need me to add the negative. If I use the outer surface, I was going to have to put the negative sign there to put it in the right location. So let's hit enter. Let's apply. And then we have to do the same thing on this side. So let's do it the other way. So it's just we kind of cover that too. Again, just to make sure, this distance is 18 inches away from it. And notice that in my the measure window, I have two dimensions. I like to use it that way. I have dual units active. You can also select inches there. That way, when you measure something, it shows you millimeters, and also it shows you in inches. So it just saves time. If you don't want to do math, you can just do the same thing as well. So I have 18 inches here as well. I'm going to use the outer surface this time. Select the outer surface here and select the midpoint of the 1 by 4 in the middle. Expand the origin plane and find the plane that's in the middle, which is YZ plane. Notice that I put it right over there, and we're going to enter 9 inches. Now, it puts it in the opposite direction when I enter positive 9 inches. So I go back and enter a minus sign and um, hit apply. Oh, I did the wrong thing because now it's not going to be 9 inches because now we are doing it from the outside, so we have to add 4 more, which is the width of this piece. So it's going to be 9 plus 13. So it's 9 plus 4. It's going to be 13. So minus 13 inches. Hit apply. Oh, it didn't like it. Oh, there it is. Right here with the mate solution. Okay. Yeah, I have this palette now. I can kind of, I can even put holes here and add some nails that I can upload from McMaster-Carr, and I can just create work instructions of each dimension and how they need to be assembled and send it to the production floor. And that way, obviously, this is a very standard size palette, which would be no problem for the people on the floor. But as it gets complicated, these CAD files and work instructions can be very helpful to increase efficiency on the production floor. So this is where the pallet jacks and forklifts would go in and pick up the product, which is mounted on the pallet and basically loaded in the truck or in a container. Or the customer can move it around wherever they want to install the product. So this was a quick example of the mate and flush constraints. I know, many of you are already saying that, there are so many other ways to do the same thing. As I said, there are configurations. You can change the pallet size without, designing another pallet just by going in the parameters and changing those values. You could have used mirror patterns to uh, generate more components without having to constrain them one by one. Or I could have used rectangular patterns. I could have done so many different things to create this assembly with less clicks in less time. But in this video, we wanted to highlight the mate and flush constraints to just kind of get more familiar with them and understand how they work. More you use it, more familiar you get, and you don't even have to worry about, which one you need to select in an assembly. And after many, many years of CAD experience, I still sometimes select the wrong solution because I'm trying to do everything really fast, probably to meet a deadline. And if that happens to you too, that doesn't mean that you're doing a bad job. It happens to everyone. So just go ahead and try different options and understand why you're getting certain errors, and go back to edit the feature and try the different solutions and see which one works for you. And that's the best way to learn, really. But thanks for watching, and see you in the next video. We're going to continue to talk about the other constraint types and the assembly mode. See you in the next video.